We're on page 46, and we're going to do 3 problems here. We're going to do number 24 right here. Then we're going to do 28. And finally, we're going to finish off with number 31. So we'll do 3 problems for this from this page. And if we start with the first problem, we're told that at a charity fundraiser supper, a total of 387 people were fed. They charged $6.80 for adults and half price, in other words, $3.40 for children. So right away we know that if we let X equal the number of adults and Y equals the number of children, the total is X plus Y equals 387. So this is strictly a number thing here. We're counting the number of adults, we're counting the number of children, and the sum of the two is 387. Now that gives us one equation. Now we're going to use this amount if they took in $2,444.60. How many adults and how many children were there? Well, we're going to multiply. We have to calculate the revenue from adults, and that is basically the cost per adult, which is $6.80 times the number of adults. Let's just say, for example, there were 10 adults. Well, if there were 10 adults and the cost per adult was $6.80, then the revenue from this would be $68. So we're going to, the total revenue, which is $2,444.60, comes from 2 places. It comes from the revenue for adults, and it comes from the revenue from children. So the revenue from adults is this, and the revenue from the children is that. If we add this to that, we should get $2,444.60, which is our second equation. Now, what we're going to do is we're not going to use elimination here on these 2 equations. We've got this equation and we've got that. Because the X and Y have very low coefficient, might be easier just to do substitution. It doesn't say that we can't do elimination, but you can see here that I can solve this for X and say X is 387 minus Y if I transpose this from the left to the right. And then I substitute this in equation 2. Instead of the X, I'm going to write 387 minus Y. So I have 6.8X, 387 minus Y in brackets. And now you'll see that this total equation only has one variable in it, and that's the variable Y. So if I use the distributive rule and I multiply 6.8 times 387, I get $2,631.60. The 6.8 times the minus Y gives me minus 68Y. This term stays the same. And so now what I'm going to do is say minus 6.8Y plus 3.4Y gives me minus 3.4Y. And I'm going to bring this from the left to the right and change its sign. So I have the variable on the left and the numbers on the right. This minus this gives me minus 187. And now I'm going to divide this term by minus 3.4. I get Y. I divide this term by minus 3.4 and I get 55. So I now have the, if I look at Y, I go back. Y is the number of children. So I have the number of children. Now I'm going to substitute Y equals 55 into equation 1. So equation 1 was X plus Y equals 387. And so if I solve this for X, the transpose the 55 from the left to the right, I get 387 minus 55, I get 332. So all I'm doing is taking equation 1, x plus y equals 387, replacing the y with the 55, and solving for the x. So now I check the answer with equation 2. I know that the number of children is 55. I know the number of adults is 332, so I'm going to check my answer with equation 2. Here's equation 2. The left side is 6.8x plus 3.4y. I know the number of adults, x, is 332. The number of children, y, is 55. So there's my revenue from the adults. There's my revenue from the children. I get $2,257.60 as my revenue from adults. $187 revenue from children. Add that, I get $2,444.60. And I look on the right side of this equation and I get exactly the same answer. So since the left side equals the right side, we're assuming that the calculation was done correctly and we have the correct number of adults and children. So here on number 28, we're told that a company rents its car for a daily fee plus an additional charge per kilometer driven. So the breakdown is if a person spends $170, it was rented for 5 days and driven 300 kilometers. So what we don't know is what the charge is for each day and what the charge is for each kilometer. That's really what they're asking us. Find the daily fee and find the charge per kilometer. And we have $178 for a car that was rented for 5 days and driven 300 kilometers. So that information will give us equation 1. And $197 for a car rented for 4 days and driven 300 kilometers. That'll give us equation 2. So let x equals the dollar charge per day for a car, which we don't know. Y equals the charge per kilometer driven. So to derive the first rental, this should say to derive the equation for the first rental, equation 1, there are 2 parts. So first of all, we have the number of days rented times the cost per day. So we're told that it's rented for 5 days, but we don't know the cost per day. So there's the charge per day, 5x. So that's the rental cost. And then the number of the kilometers driven, which is 300, times the cost per kilometer, which is y, gives us the cost of the mileage. So the rental cost plus the cost of the mileage gives us the total cost. So 5x because it was rented for 5 days, and 300y because it was driven for 300 kilometers. That gives us the total cost. So that gives us equation 1. Now in the second one, we're told that it's rented for 4 days. We don't know the cost per day, which is x, and it's driven 500 kilometers, and we don't know what the cost per kilometer is, so we call that y equals 197. So we now have 2 equations, and we're going to eliminate the x term, multiply equation 1 by -4. -4 times 5x gives us -20x. -4 times 300y gives us -1200y. And -4 times 178 gives us -712. We're going to multiply equation 1. This should be equation 2, actually. So this should read the number 2 here. So we multiply this by 5. We get 20x. We multiply this one by 5, we get 25y. And if we multiply this one by 5, we get 985. So there's just an error here. This should read equation 2. And let me just change that. I'm just going to change that to equation 2 here. Here we are. So you'll notice that we're eliminating the x term. We've got minus 20x and plus 20x. So these are always opposite in sign. Okay, same magnitude, opposite in sign. When I add this, I get rid of the x term. 2500 minus 1200 gives me 1300y. And 985 minus 712 gives me 273. When I divide this by 1300 and this by 1300, I get 0.21 or $21.21 per kilometer driven. So I now know the y value. What is the cost to drive per kilometer driven? So it costs 21 cents. Or $0.21 per kilometer driven. Now I'm going to substitute y into equation 1. And if I do that, right over here, I'm going to substitute this into equation 1. I get 5x plus 300y. Now instead of y, I'm going to write 0.21 equals 178. And so 300 times 0.21 gives me 63. Transpose the 63 to the right side. 178 minus 63 gives me 115. 5x equals 115. Divide this by 5, I get x. Divide this by 5, I get 23. Or it costs $23 a day to rent the car. So we now have the x, which is the cost per day for rental. We have the y, which is the cost for the kilometers driven. And the sum of the two would give us what we paid. Okay, so we check the answer with equation 2. Equation 2 says that 4x, let's go back up here, 4x, find the original equation right here. 4x plus 5y equals 197. So here we've got the 4x plus, 4x plus 500y equals 197. So we got 4x plus 500y. Now we know the x is 23. We know the y is 0.21. 4 times 23 is 92. 500 times 0.21 is 105. 92 plus 105 is 197. And if we check, then the right side of the equation is 197. So we have the right values for the cost of the rental for the day, and we have the right cost for the kilometer rate. So the last problem on this page, here we have a counterweighting system on this pan. We have 43 kilograms, and over here we have 2 square objects, and here we have 3 round objects. Here we have 1 square object, and we have 2 round objects. So I'm going to denote the square object by y and the round object by x. You can see here. So this is a counterbalancing. We want find the weights of the square and round objects. So what we have to do is this 43 is counterbalanced by 2y and 3x. So 3x plus 2y equals the 43. That's equation 1. On the second counterweight, the 27 here, we have just the y plus 2x. So 2x plus y. So we have the two equations. We're going to substitute in here. We're going to say y equals 27 minus 2x and substitute it back into 1. Okay, so first from equation 2, y equals 27 minus 2x. Put it into 1, equation 1, instead of 3x plus 2y. Here's the y term, which is the 27 minus 2x equals 43. And now we remove the brackets. 3x plus 2 times 27 is 54. 2 times minus 2x is minus 4x. And the right stays as 43. 3x minus 4x is minus x. And 43 minus the 54 is minus 11. So if minus x equals minus 11, x equals 11. So now we substituted, we found the value of x, which is the round object. And we want to find the square object. We go back into equation 1. We substitute x equal 11 into equation 1. 3 times x plus 2y equals 43. There's equation 1. 3 times 11 is 33. Plus 2y equals 43. Bring the 33 from the left to the right. I get 2y equals 43 minus 33. So 2y equals 10 and y equals 5. So I now know that the round object has a weight of 11 and the square object has a weight of 5. Let's check the answer using equation 2. Equation 2, let's just take a look at it right over here. 2x plus y equals 27. So 2x plus y on the left side. We said that y was 5. X was 11. So 2 times 11 is 22. Y is 5. 22 plus 5 is 27. The right side of the equation is 27. Now, by the way, just to go over here, I use substitution here. I don't have to. I could have eliminated. I could have multiplied equation 2 by minus 2, and I would still come out the answer. So sometimes you can use both substitution. You can use either substitution or elimination quite easily, and it doesn't really matter. But whatever happens, you're going to come out with the same answer, even though the arithmetic and the calculation may be different.